Okay, so first here's my audience. Okay, so consider how your life would be impacted without the convenience of an automobile powered by an internal combustion engine. What would you do? How would you get from place to place? As you can see, internal combustion engines are very important for daily life. So I'd like to focus on three main points involving internal combustion engines. First of all, how they work and the main parts within an internal combustion engine. Some advancements companies have made throughout the years on internal combustion engines. And then finally, how Honda specifically has made advancements in fuel efficiency and performance throughout the years. So, with that being said, first, the internal combustion engine. So the way this works is a very nice combination of air and fuel, which comes in the intake, usually the air intake of a car. And through here, there's a valve that opens, and if you can see here, this camshaft, it pushes down on the valve and then rises up, and this has a spring going through here, which allows for fuel and air to go into the chamber where the piston is and connected to the crankshaft and the connecting rod. So the spark plug, then once that air and fuel, which you know combustion reaction is fuel, air, and then some sort of ignition, that sparks that, it pushes this piston down, moves this connecting rod, and then turns the crankshaft. Well, this crankshaft turns in a 360 circular motion and is continuous. So with that, the piston goes down and comes back up, and it needs for that gas that's in the chamber needs to release somewhere. So this over here, the camshaft, circles around just like the intake valve and allows for this valve to push down and let the air and whatever left out through the exhaust. And really that's why they're so popular, is because all you need is fuel and air. Well, air is rapidly abundant and fuel is pretty abundant as well. So it makes for a nice motor in a car. So my second point is actually some advancements that have been made with the internal combustion engine, specifically focusing on the cams, the valves, this is for the intake and the exhaust, with the piston and what's actually called a rocker arm. So the picture I showed you before was of a dual overhead cam engine setup. This is a single overhead cam setup, which is actually came about before the dual overhead cam, and was very effective for quite some time. But with this movement, you only have one cam, and it pushes these rocker arms up and down, which allow for here fuel to come in, and then after the reaction takes place, moves the piston down, and it comes back up, then pushes this rocker arm to open this valve here, which allows for the exhaust to come out. So that was good for quite some time, but it shortly got overturned by the dual overhead cam, just because if you could do this independently, it allowed for quicker motion of what I showed you earlier, the crankshaft, and that allows for higher revs per minute, which is RPMs, and that's better performance. And along with that, the difference between the two, this one you can have multiple valves per piston, whereas here you're limited on the amount of valves you can have because you have this rocker arm set up and you only have a single cam going through. So that's another good thing about the dual overhead cam and the advancement through some time with an internal combustion engine. And then thirdly, I'd like to show you the Honda advancement, which is a little bit more intricate, and I like it personally. I have a motor that has this setup. It's a 3-stage VTEC is what it's called. It's iVTEC. So here what happens is we're focusing again for fuel efficiency and performance advancements on the top of the motor, where you've got the valves, and then you've got the rocker arms, and here is actually the camshaft with different sized lobes. So before, the whole thing was there's only one lobe and it pushed one rocker arm. Well, now you've got 3 different type of lobes, and they're all set up for different fuel efficiencies and revs per minute. So here, this camshaft, the lobe here is circular and completely, it's the same size as the whole camshaft, and it doesn't move this rocker arm at all. So this valve actually does not move, and what's happening is there's only one valve moving for intake of air and fuel, while there's 2 valves moving for the fumes to exit through the exhaust, just like shown up here. That's at low revs per minute, so low RPMs. And then once you step up to about a mid-range, what happens is oil gets pushed through a solenoid, which then locks in the system between this rocker arm and this rocker arm, and is moved by then this lobe on the camshaft, and it allows for both to be moved, both of the valves to be moved down, and for air and fuel to be put in the system, and then exhaust, you still got your 2 valves opening. And then with this third, you have a system that locks here, solenoid, and it pushes these pins out, locks all 3 of them, and operates on the largest valve, or the largest lobe on the camshaft. And that allows for the maximum amount of performance, a maximum amount of fuel and air to be put in the system, while both, once again, the exhaust, it has 2 valves for the exhaust. So once you get into that higher revs per minute range, you're dumping more fuel and air in, which in turn lets you have higher performance, but you're not sacrificing fuel efficiency because you can stay at lower RPMs and be using less fuel with this setup. So that's why I like this 3-stage VTEC setup. So with that being said, internal combustion engines are very, very important for daily life. Everyone uses them. Everyone has them in their cars. So they're very important. And actually, the advancements being made are important as well, because this is saving us money in the long run. This is saving everyone money. So this is important to understand and know why it's happening. And that's all. Thank you.